Previously we have seen that if a vector v is rotated around an axis n, which is a unit norm or unit length vector, by an angle theta, then the new position of the rotated vector v prime is equal to r times v, where r is a rotation matrix 3 by 3, which can be expressed by this formula in terms of the axis of rotation and the angle of rotation n and theta respectively. So I shall write this formula on top of this page first. R is equal to 1 minus cos theta times n transpose plus cos theta times identity matrix plus sin theta times n cross q symmetric form of n. Now here are some exercises for you, which I believe you must solve before proceeding further. And so here are the exercises. Number 1, given this form of the rotation matrix, prove that n, that is the axis of rotation, is an eigenvector of R, that is the rotation matrix. Next, what is the corresponding eigenvalue? So what is the corresponding eigenvalue corresponding to the vector n? Question number 2. So that for any k in R, for a scalar k, R times kn is equal to the magnitude of this vector is equal to k. Justify why this has to be true. Next, 3. I should rather write modulo here because k can be negative. Next, 3. Given a rotation matrix R, given a rotation matrix R, a 3 by 3 rotation matrix, find the axis of rotation. So what is the axis of rotation when a rotation matrix is given? Next, question number 4. Given a 3 by 3 rotation matrix R, how many eigenvalues does it have? Next, question 5. Note that eigenvalues can be both real or imaginary. But if R is a real matrix, then eigenvalues occur in conjugate pairs. I hope you know this. Then the question is, how many real eigenvalues can a three-dimensional rotation matrix, how many real eigenvalues can a rotation matrix have? Further, if all three eigenvalues are real, firstly, whether it's possible or not, you have to think that first. And if it is possible that all three eigenvalues are real, then what kind of rotation is it? Can we say something special about this rotation if all three eigenvalues are real? Next, question number 6. If all three eigenvalues are real of a rotation matrix R, then justify that R is equal to I, identity matrix 3 by 3. Further exercises for you. So given you know the form of R, which I shall write once again for your reference, which is 1 minus cos theta times n transpose, where n is the axis of rotation, plus cos theta times identity matrix, plus sin theta times n cross q symmetric form of R. Now, given this form of the rotation matrix, question for you is to find the trace or the sum of the three diagonal elements of the rotation matrix R in terms of theta and the axis, maybe axis of rotation. Next question is, if a vector n is such that the norm of n is equal to 1, that is, if n is a unit norm vector, so that the trace of the matrix A and n transpose is equal to n, where A is a scalar. Next question number 9 for you is given a rotation matrix R, find the angle of rotation, that is theta, in terms of the element of R. How will you do that? Then question number 10. It can be first express R, a rotation matrix, in terms of the axis of rotation and theta, the angle of rotation, which the answer to this question is already given here for reference. Then once you have it, once you have R in terms of n and theta, decompose R as a sum of a symmetric and an asymmetric matrix, where both symmetric and asymmetric parts should be expressed in terms of n and theta. Next question 11. Given a matrix R, so here R need not be a rotation matrix in this question. Given any matrix R, so that R can be uniquely decomposed as a sum of a symmetric and an asymmetric component or asymmetric matrices. So most important thing in this question is to show that this decomposition is unique. Question number 12 is given a rotation matrix R, find the axis of rotation n and the angle theta without finding eigenvectors. So without using the concept of eigenvectors, how to find the angle and axis of a rotation from a given rotation matrix.